Welcome back to our discussions on magnetic effects of electric current. In this episode, we are going to discuss about the principle, construction and working of an electric motor. We are going to discuss about the force on a current carrying conductor in a magnetic field. An electric current flowing through a conductor produces a magnetic field which exerts a force on a magnet placed near the conductor. A French scientist, Anne-Marie Ampère, suggested that the magnet must also exert an equal and opposite force on the current carrying conductor. It is this force, due to the magnetic field acting on a current carrying conductor, sets the rod roll. Now we are going to discuss the direction of the force on a current carrying conductor in a magnetic field. If an aluminium rod is suspended horizontally by a wire between the poles of a horseshoe magnet and the current is passed through the wire, then the aluminium rod is displaced towards the left. If the direction of the current is reversed by interchanging the terminals of the battery, the direction of the displacement is also reversed and it is towards the right. The displacement of the rod suggests that the force is exerted on the current carrying aluminium rod when placed in a magnetic field. It is also observed that the force exerted is maximum if the conductor is perpendicular to the magnetic field. If the direction of the magnetic field is changed vertically downwards by interchanging the poles of the magnet, it is again observed that the direction of the force acting on the current carrying rod gets reversed. That is, initially the displacement of the rod was towards the left and now it is towards the right. Experiments have shown that the displacement of the rod is largest or the magnitude of the force is highest when the direction of the current is at right angles to the magnetic field. Sir John Ambrose Fleming, an English electrical engineer and physicist who first invented the vacuum tube, established the left-hand rule to find the direction of the conductor. According to the rule, stretch the thumb, forefinger and the middle finger of the left hand such that they are mutually perpendicular to each other. The first finger points the direction of the magnetic field, the second finger the direction of the current, and the thumb points the direction of the motion or force acting on the conductor. Now we are going to discuss about an electric motor. An electric motor is a rotating device that converts electrical energy into mechanical energy. It is based on the principle that the current carrying conductor in presence of the magnetic field experiences a mechanical force. It is used as an important component in electric fans, refrigerators, mixers, washing machines, computers, MP3 players, etc. An electric motor consists of a rectangular coil of insulated copper wire wound over a soft iron core placed between the two poles of a magnetic field such that the arm AB and CD are perpendicular to the direction of the magnetic field. The ends of the coil are connected to the two halves of the split ring P and Q, the inner sides of which are insulated and attached to an axle. The external conducting edges of P and Q touch two conducting stationary brushes X and Y. Current in the coil ABCD enters from the source battery through conducting brush X and flows back to the battery through brush Y. The current in the arm AB of the coil flows from A to B, and in the arm CD it flows in the opposite direction from C to D. On applying Fleming's left-hand rule, we observe that the force acting on the arm AB pushes it downwards while the force acting on the arm CD pushes it upwards. Thus the coil rotates in the anti-clockwise direction. At half rotation, Q makes contact with the brush X and P with brush Y. Therefore, the current in the coil is reversed by the split rings and flows along the path DCBA. The reversal of the current also reverses the direction of the force acting on the two arms AB and CD. Thus, the arm AB of the coil that was earlier pushed down is now pushed up, and the arm CD previously pushed up is now pushed down. Therefore, the coil and the axle rotate another half rotation in the same direction. The reversing of the current is repeated at each half rotation, giving rise to a continuous rotation of the coil and the axle. The split rings that reverses the direction of the current is called the commutator. The carbon brushes is a sliding contact used to transmit electric current from a static to the rotating part and also ensures a spark-free commutation. And the soft iron core on which the coil is formed plus the rings is called the armature that enhances the power of the motor.